Okay, let's finish up factoring. Notice you always check, can I factor out the GCF? Then you always check, can I factor more? If the power's 1, then you're done. So first one, 2 terms, so I'm looking for difference of squares. And what are we squaring? That'd be x squared plus 1, x squared minus 1. So this would be x squared plus 1, x plus 1, x minus 1. Difference of squares. There is no sum of squares, so we stop there. Tricky problem. Most people get this one wrong. Here, factor out the GCF. So it'd be x squared plus 2x plus 1. Then, can I factor this? Well, what are the factors of 1 that add up to 2? Well, that'd be x plus 1, x plus 1. So it'd be 3 times x plus 1 squared. Here, factor out the GCF is 2. So it'd be x squared plus 6x plus 5. Then what are the factors of 5 that add up to 6? So it'd be x plus 5, x plus 1. Woohoo! We are a crankin'. Now, we talked about this in class. Do you remember discriminant? Now, there's only one question on the test, but hey, every point counts. So, the discriminant is from the quadratic formula, and it's b squared minus 4ac. So, b is the term or the coefficient of x to the first power, coefficient of x to the first power. So negative 4 squared is 16, minus 4 times 1 times 4 is 16. It's 0. So if the discriminant is 0, you're going to have one solution, or technically one rational root or one real root. Here we go. So b squared, that's negative 7 is b, so that'd be 49. Minus 4 times 2 is 8, times 2 is 16. So it's 33. If it's a positive number, you have 2 real roots. Or if you want to spell it out, 2. And then this one, b is 1, 1 squared is 1, minus 4 times 3 is 12, times 3 is 36. That'd be negative 35. And there's no real answers. There's 0 real answers when the discriminant's negative. I'm not a big proponent or the discriminant. I don't think it's that important, but one problem won't hurt ya. Here we go. Do you remember square roots? Oh, very important. Next year in geometry, you're going to see this all the time. Simplifying the square root of 50. Excuse me. Oh, that wasn't good. So we break this up into the perfect square and not perfect square. 50 is 25 and 2, and the square root of 25 is 5. 200 is 102. Square root of 100 is 10. 80, let's see, you could do 4 and 20. Oh, the square root of 4, sorry, and square root of 20. That's 2 square root of 20, but 20 is also a perfect square. It is 4 and 5. Square root of 4 is 2, times 2 is 4. Good land. Murphy's starting to lose it. This one, I'm going to break this up into 2 square roots. Perfect squares, not perfect squares. 25 is perfect. Even power you need for a square root. So y to the 5th would be y to the 4th. You'd have a little y left over. So this would be square root of 25 is 5 times 4 is 20. Square root of x the fourth is x squared. Y the fourth, the square root is y squared. Yoo-hoo. Here, we're going to break it up. Perfect square, not perfect square. 18 is 9 and 2. Odd power, so I got to take off one of them. Odd power, so I'm going to take off one of them. Square root of 9 is 3. Square root of x is 16th is x to the cubed. Y to the fifth, just divide the power by 2, just divide the power by 2, just divide the power by 2. Now this is tricky. Whenever you have a fraction, you just take the square of the top and the bottom. And you can't have a radical in the bottom, so you multiply the top and the bottom by the square root. So we'd have square root of 15, this times this, over square root of 5. Square root of 5 is square root of 25. So it'd be square root of 15 over 5. This one, I'm going to simplify the fraction. That'd be square root of half. Reduce it. Then square root of 1 over square root of 2. So I'm going to multiply top and bottom by square root of 2, this number. And square root of 2, square root of 1 is 1. So times square root of 2 is just square root of 2. Square root of 2, square root of 2 is square root of 4, and the square root of 4 is 2. So this one, break it up 4 and 3. 75 is 25 and 3. So it's 2 square root of 3, 5 square root of 3. So it's 7 square root of 3. Woohoo, we are cranking.